In this video, I'll be helping you with the ALEKS problem type called Solving a Rational Inequality, Problem Type 2. This time, our inequality has a quotient on the left-hand side and the right-hand side. And to solve inequalities, I need one of those to be 0. That would allow me to look at either being positive or negative as a way of finding our solution. So in my first step, I'm going to move one of these quotients over to the other side. And while it doesn't matter which I move, I like having the 0 on the right-hand side. So here I will subtract x minus 5 over x minus 3 from the right-hand side, meaning that I would also have to subtract x minus 5 over x minus 3 from the left-hand side. This would give me on the left the original x minus 1 over x plus 2 minus x minus 5 over x minus 3. And now the right-hand side would just be 0. And since I'm just adding and subtracting, the direction of that inequality would stay the same. And from here on the left-hand side, I need to express this as a single quotient. So I'm going to need to get a common denominator. And here the first quotient has a denominator x plus 2. The second quotient, x minus 3. My common denominator would have to have both of those factors. So to get a common denominator, I'll need an x minus 3 on this left-hand side, and I would also need it in the numerator, x minus 3, so that in effect, I'm just multiplying by 1. Then on the right-hand side, I need the x plus 2 in the denominator, so I would need to also multiply the numerator by x plus 2. This would allow me to have a common denominator of x minus 3, x plus 2. In the numerator, I'm going to need to simplify as much as possible. So distributing that first x minus 3, I would start distributing with the x. X times x is x squared, and then x times minus 1 is a minus x, followed by distributing the minus 3. Minus 3 times x is a minus 3x. And a minus 3 times minus 1 is a plus 3. I'll be careful with my minus sign here by putting that second part in parentheses. Here I'm also distributing first the x times x is x squared, then x times plus 2 is a 2x, distributing the minus 5 times x is minus 5x, and minus 5 times 2, a minus 10, all inside those parentheses. From here, I can start to simplify that numerator, everything else being the same. In this first bit, I have a single x squared, but then a minus 1x and a minus 3x would give me a minus 4x. Bring down the plus 3. I'll keep these parentheses for now. In the second part, I also have a single x squared, but the 2x and the minus 5x can combine to be a minus 3x, bringing down the minus 10. And then from here, continuing to simplify the numerator, I can distribute that negative to be a negative x squared, positive 3x, and then a plus 10. This allows me to combine like terms. The x squareds will cancel, and the minus 4x and plus 3x would give me a minus 1x. The plus 3 and the plus 10 would combine to be plus 13. From here, I would want to check to see if anything cancels with the denominator. And since nothing does, I have 3 factors here that I want to find where they equal 0. The first, in the numerator, negative x plus 13 equals 0. To solve for x, we can subtract the 13 over. To have negative x equals negative 13, solving for x by dividing both sides by negative 1, I have x is equal to 13. And then I can look at the factors in the denominator to see where they're equal to 0. Starting with x minus 3 equal to 0, I could add the 3 over to the other side to have x equals 3. And then the other factor in the denominator, x plus 2, setting that equal to 0 and solving for x gives me an x equals negative 2. So I have these 3 points of interest where a factor on the left-hand side would be 0. I would want to create a table with each one of those 3 factors from smallest to largest. and then look at what happens to each one of these factors over the different areas. Starting with that numerator, we have negative x plus 13. If I plug in a value here for x that is larger than 13, like say 14, that would be a negative 14 plus 13. This would give me a negative for any value larger than 13, and a positive for any value less than 13. For the first factor in the denominator, x minus 3, if I plug in a value greater than 3, this factor would be positive. Any value less than 3 would be negative. And then the last factor, x plus 2, any value greater than negative 2 that's substituted in would give me a positive. Any value less than negative 2 would be negative. And from here, since I have this quotient on the left-hand side with multiplication and division, if I have two negatives and a positive, like in this first region, this would give me a positive when I substitute into the quotient. If I only have one negative and two positives, that would be negative. All positives would be positive. One negative and two positives would be negative. And since I'm interested in where this quotient is greater than 0 or positive, that would be this range and this range. To describe these two areas, I would start with the one on the left. This is negative infinity, non-inclusive, to negative 2. Now, negative 2 is non-inclusive for two reasons. First, there's no equals underneath our inequality. And even if there were, negative 2 would give me a 0 in the denominator. So I would want to exclude it either way. And then the second region here is 3 to 13. I'm also excluding both of those endpoints, both because there's no equal sign is why I'm excluding the 13. And even if there were, I would still exclude the 3 since that would give me a 0 in the denominator for this factor. So my solution area is described here.